Have you ever looked up at the sun and just wondered, how does it do that? For decades, that's been one of humanity's biggest, most ambitious quests, to build a machine that can actually capture the power of a star and bring it right down here to Earth. And this isn't science fiction, folks. This is the very real, very exciting pursuit of nuclear fusion. But before we can even think about building our own star, we've got to start with a really basic question. How does our sun produce that staggering, seemingly endless amount of energy day in and day out for billions of years? So what is the sun's secret power? Well, the answer lies in a process that is basically the engine of our entire universe. It doesn't just fuel our sun, it fuels almost every star you see twinkling in the night sky. And it's called nuclear fusion. Okay, let's break that down. At its heart, nuclear fusion is kind of what it sounds like. Imagine squishing two things together so hard they become one. Except here, we're talking about the tiny hearts of atoms, their nuclei. We're forcing them to fuse into a single, heavier nucleus. And the moment they combine, bam, an absolutely enormous amount of energy is released. And when I say enormous, I mean, well, just look at this number. The scale is just mind-boggling. Our sun is one colossal fusion reactor. Every single second, it burns through 620 million metric tons of hydrogen, turning it into helium. That is an insane amount of material being converted into pure energy every single second. That's the power we're trying to bottle. All right, so you've probably heard of nuclear energy, right? But this is a whole different ballgame. So what exactly is nuclear fusion? And how is it different from the nuclear power plants we already have? Let's get into it. Okay, this is a big one, because people get these mixed up all the time. But it's actually pretty simple. Over on the right, you've got fission. That's what our current nuclear power plants do. They take big, heavy atoms like uranium and split them apart to release energy. It's a splitting process. But fusion, on the left, does the exact opposite. It takes really light atoms, like hydrogen, and joins them together. One splits things apart, the other joins things together. That's it. So what's the recipe for cooking up fusion here on Earth? Well, the most promising one involves two special versions, or isotopes, of hydrogen, called deuterium and tritium. First, you take your fuel. Then the tricky part. You have to squeeze them together with incredible force to make them fuse. And what do you get out of it? Some harmless helium, a super high-energy neutron that we can use to generate power, and of course, a massive burst of energy. Now, it might sound straightforward on paper, but this brings us to the real heart of the problem. Trying to recreate the conditions inside a star, right here on Earth, is, without a doubt, one of the greatest scientific and engineering challenges humanity has ever taken on. So here's the billion-dollar question, right? How do you hold on to something that's hotter than the core of the sun? You see, the fuel for fusion isn't a solid, a liquid, or even a gas. At these insane temperatures, it becomes a fourth state of matter called plasma, a superheated, electrically charged soup of atoms. And as this quote says, the key problem is figuring out how to contain it. And this table, wow, this really puts the challenge into perspective. The sun, you see, has it easy. It uses its own immense gravity to squeeze and contain its core, which is about 15 million degrees Celsius. We don't have a spare sun's worth of gravity lying around. So to make up for it, our reactors have to get even hotter. We're talking over 150 million degrees. That's more than 10 times hotter than the sun's core. And since gravity's not an option, we have to get really clever, using things like powerful magnetic fields or giant lasers to hold it all together. Now, despite how incredibly difficult this is, scientists and engineers all over the world are locked in a race to solve this problem, and they're mostly heading down two main paths. So here are the two big ideas. On one hand, you have magnetic confinement. This approach uses incredibly powerful magnetic fields to create a sort of invisible bottle, often in a donut shape called a tokamak, to hold the superhot plasma so it never touches the walls. The other approach is inertial confinement. This is more like setting off a tiny, perfectly controlled explosion. You take a tiny pellet of fuel and blast it from all sides with some of the world's most powerful lasers, crushing it so fast that it fuses before it even knows what hit. Now, this whole quest isn't something that started yesterday. We've been chipping away at this for almost a century. The first little spark was back in 1934. Then, in '58, the first controlled fusion in a lab. Fast forward to 1997, and a machine called JET was producing some serious fusion power. But look at how things are speeding up. In 2022, a huge breakthrough happened. A US lab actually got more energy out of the reaction than they put in. That's called break-even, and it's a massive milestone. The next giant leap is a huge international project called ITER, which is aiming to prove this can work on a power plant scale. So, after all this effort, all this time, money, and incredible brain power, you've got to ask, what's the ultimate goal? Why are we even trying to bottle a star in the first place? Well, the answer is the promise of something truly world-changing. This is why it all matters. First, the fuel. One of the main ingredients, deuterium, can be filtered from ordinary seawater. There's enough in the oceans to power humanity for millions of years. It's practically limitless. Second, it's clean. It produces zero carbon emissions. Zero. And third, it's incredibly safe. There's no chain reaction, so a meltdown like in fission is physically impossible. Plus, it doesn't create the kind of long-lived, nasty radioactive waste we worry about now. It's the ultimate clean energy dream. And look, this isn't just some far-off academic fantasy anymore. People with serious money are taking notice. In just one recent year, private companies in the race for fusion raised over $2.6 billion. This shows a huge shift. It's not just a government science project anymore. A real industry is being born right before our eyes. So the quest goes on. Scientists, engineers, innovators, they're all pushing the limits of what we thought was possible, all chasing this one incredible goal. It really just leaves us with one final thought. Humanity is on the verge of bottling a star. The only question left is, what will we do when we finally succeed?
For the latest in science and technology, make sure to subscribe to our channel right here.